Okay, for the 3.5, we will still focus on the first 4 objectives and skip the last application problems. Only focus the first 4. The first one we use slope intercept form to help us to draw the graph. So let's see, how can we do this? We know we call this form slope intercept form, right? Because from this equation, we can directly get what's the slope. That's the coefficient of x. And the remaining value, -2, we will get that's the y-intercept. So from this equation, we can get slope and the y-intercept. So that's called slope-intercept form. So we could use this form to help us draw the graph. So first, we will just use the intercept. We will begin with the intercept point. So here the intercept is the 0, -2. So we have the y-intercept here. Then we will try to use the slope to help us find another point. Remember, what's the definition of slope? Is the change vertically divided by change horizontally. Or we will say change in x divided by change in x. So here we already know this is 3/5. So we could start with the intercept 0, -2. 0 plus 3. -2. If 0 plus 3, I cannot write like this one. So we know the slope is if we change 3 units in y, then we change 5 units to x. That's the definition, right? If we add 3 units to y, then we add 5 units to x. So here is the y-intercept. We start with this point. Add 3 to y, so we will get y, the new y, we will have this one. -2 plus 3, 1. And we will get the new x. Add 3 to y, we should add 5 to x. So add 5 to x, we'll get 5. So we get a new point. It's called 5, 1. So we have this point too. It's 5, 1. Then we can try to connect these 2 points to help us draw the curve. Again, this is just based on the definition of our slope. Change in y divided by change in x, which means if y increase 3 units, then x increase 5 units. So y plus 3, then x plus 5 units to get 5. So we find a new point. Okay? So let's check another point, another example. This time we have this. We want to use the slope-intercept form to graph this equation. So if we are given a standard form, but we want to use the slope-intercept form, which means we should switch this one to the slope-intercept form. It's just like solve for y, right? So it's negative 4x plus 1. Now we switch this into the slope-intercept form. And from this one, we can get what's the y-intercept for this curve, this line? 0, 1. That's our y-intercept form. So how can we draw the graph? We start with the y-intercept form. So 0, 1, so it's right here. We start with this point. Now we should know what's the m here. It's negative 4. So what's the meaning? Delta y divided by delta x. So if we change, we add 4 units to add 4 units. Add 4 units to y. So that's 1 to 5. Add 4 units to y. So our y, new y will be add 4 units. We'll get 5. Then it's negative 4, so it's just like minus 1 unit to x. So our new x is equal to 0 minus 1. It's just like negative 1. So we have our new point, like x. New point is negative 1, 5. Okay, it's just like negative 1, 5. So negative 1, 3, 4, 5. So it will be like around this point. So we can connect these 2 points. It should be a straight line, sorry. It should be a straight line. We should connect these 2 points. One point is just the y-intercept. Another one is this point, point 2. How can we get to point 2? We start with the 0, 1. So first, y is equal to 1, right? But if we add 4 to this y value, from 1 to 4, we'll get 5. Similarly, change in x should be negative 1. Because plus 4 divided by negative 1, we will get this slope. So if we increase y by 4 units, then we should decrease x by 1 unit to make sure the slope is just this meaning, right? Change in y, change in x. So it will be decrease 1 unit to x from 0 minus 1 to be negative 1. We will get negative 1 to 5. Of course, you can find another point, something like if this time we want to change x first. X to increase 1 unit. So x plus 1 to x. X increase 1. So x from 0 to 1. Then y should be decrease 4 unit to y. Then y from 1 minus 4 will get negative 3. So we could also use this point, 1, negative 3, as the second point. Then plot that point to connect the 2 points to find the line. So that's the same thing. It's not necessary to be this or this. Any point you want. But make sure every time you increase 1 unit of x, you should decrease 4 unit of y. Because the slope tells us that. Every time you increase x 1 unit, you need to decrease y 4 unit. If you decrease x by 1 unit, you should increase y by 4 units. Okay? So we could use the intercept and the slope to help us draw the curve. And the second objective is to use the slope-intercept form to write the equation. So this time I have the y-intercept. It's like 0, negative 3, and we also know the slope is 1 over 4. And we need to use this information to help us to write the equation of the line. So we know y is equal to slope, the coefficient of x is the slope, so we can write. And it will be negative 3. We only pick the y value here. So our equation will be like this one. Because we know this is the slope. The coefficient of x is just the slope m. And this negative 3 is the intercept for y. Okay, so that is the slope-intercept form. We could directly use the slope and the y-intercept to help us to write the slope-intercept form of the equation. Okay, of course, we have another, let's see another example. This time, if we have the y-intercept as 0, 1 over 3, and we have the slope as negative 1. How can we write the equation? We know the slope-intercept form is just like this one, right? We use negative 1 as the slope and the 1 over 3. Then simplify. It will be like this one. So the slope-intercept form will be like this. But sometimes the question asks you to list the standard form. Now we cannot directly leave the slope-intercept form as our result. We still need to switch back to the standard form. So remember, standard form should be like this way. It could be like x plus y equals 1 over 3. So this is called a standard form. So make sure you read the question carefully. Sometimes the question asks you to list the slope-intercept form. Sometimes they tell you have to list the standard form. So let's move on to next objective about give you the slope and point. This time you have the slope, but you do not have the y-intercept. It's just a random point. How can we write the equation? Write the equation. This time we will introduce a new form of the line. It's called point-slope form. Remember, we already have two forms of the linear line, the line. It's called standard form, ax plus by equals c. And the second form, we call it slope-intercept form. We can find the slope and the y-intercept from that form. And this time we have a new form called point-slope form. So from here, we know we have the slope, and we have another point. This point is just a random point. It's not the intercept. If it's intercept, we call it slope-intercept form. It's just a random point, so point-slope form. What is the point-slope form? It's just y minus y1 equals m, then parenthesis x minus x1 here. x1, y1 is one random point on the line. It's just one random point on the line. So this is called point-slope form. So far we have three, right? Standard form, slope-intercept form, point-slope form. Okay, let's check the example. If we have slope and one random point, how can we find the equation? So this time we know slope is equal to -2. And the random point is -1, 5. So it's not the intercept. If it's y-intercept, then the x should be 0. So it's here, the x value is -1, so it's not 0, it's not y-intercept, it's a random point. Which means we should use the point-slope form to help us, right? Y, we just copy y. Y is the variable here. And y1, what's y1? It's the random point. So this is x1, this is y1, so -5. Here, we will just use the -2 to replace the m. Again, in the parentheses, we copy down the x minus x1. What's x1? x1 is still the random point. So it's -1. So we will simplify this too. It's just like x plus 1. So y minus 1 equals 2 minus 2x minus 2. So when you do use the distributive rule, make sure, be very careful. Okay, so after that, we will get this. Or sometimes we will get this. Depends on the question. If question asks you to list the slope-intercept form, then we pick this one. If the question needs you to list the standard form, then we prefer this one. Okay? So we could use point-slope form to help us to list the equation when we only given the slope and one random point. So the last objective is we only have 2 points. Use 2 points to write the equation. Use 2 points to write the equation. So this time we do not have the slope. We only have 2 points. So what shall we do? We will say first step, we need to get the slope by 2 points. Okay, we still need to get the slope. Slope is the first step. Then we will use one of the 2 points to use one of the 2 points and the slope we have to use the point slope form to have our equation. Let's check an example to help us understand. Use slope, because for step 1 we already get the slope, then we random pick a point to get the equation. Use, of course, here we should use point slope form. So let's check the example we have. If we have these 2 points, we only have 2 points, 2 random points. So first step, we should get the m. How can we get it? We have 2 points. Of course, we can have the change in x divided by change in y. Change in y divided by change in x. Change in y divided by change in x. So here, this is x1, y1, then this will be x2, y2. So we will use 4 minus 5, y2 minus y1. Then x2 minus 3 minus x1. We will have negative 1 over negative 5. We will have 1 over 5. 1 over 5. So we already get the slope. Slope is equal to 1 over 5. Then the second step, we only need to pick any one of the points. So maybe we just pick this one. So we have slope and another point. We just use the point slope form. Remember what's the point slope form? Y minus y1. So here, this will be x1, y1, so minus 5. And this is our slope. In the parentheses, we should use x minus x1. So x1 is here. Is 2, so we minus 2. So after that, we could write it into the this is called slope-intercept form. But sometimes the question asks you to list the standard form. So we could time 5 to both sides. So it will be like x minus 5y negative 25. So I made a little bit of mistake. So here it should be okay. So here is the standard form. Of course, sometimes the student will get this. So these two are equivalent to each other. They're both correct. They're both correct. They're the same line. So if we times -1 to both sides, we will get this lower one. So they are equivalent to each other. Both are correct. Okay? So that's for this 3.5. We talk about the first 4 objectives and skip the last one to solve the application problem.